Okay, so this is to go through some of the tasks for the first lab of the CO4073 module. What I've done is I've copied the tasks as comments into the project, and we're going to work through the various tasks. So the first one asked us to create a method. It says we need to call the method hello CO4073 and have it return a string, and that string has to be hello CO4073. And it suggests using this hello world method up here as a guide, clicking the shaded background on the brace opens up the method so we can see it on the separate lines within which it's been written. So let's start this one. We'll write each method under the comments. Key thing to just keep in mind here is that we are still inside the main class. So we have an open brace here and there's a closing brace right at the bottom down there. So we're still inside that. And we're obviously not inside any of these other existing methods. So let's write the first one here. First thing is, at the minute, all the methods we're writing are static. So we're going to start them all with the static keyword. The next thing is it tells us this method needs to return a string. So we're going to set the return type to string, just like that. It also tells us the name of the method. So for simplicity, I'm just going to copy the name of the method and paste it there. And it doesn't need any information in order to do its job. If we look at the hello world method, there's nothing inside the brackets here because we can run the method without any other information. So we can leave the brackets for our method empty. We need braces for the logic for our method, and then within the braces we're going to write the solution. So in the case of the hello world one, we simply declared a string literal with the word hello world and returned it. We could have done it in 2 lines. So to show a different approach to doing this, I'm going to create a string. I'm going to call it greeting, and I'm going to assign it the value of hello CO4073. Don't forget we need a semicolon to end the line, and then I am going to return that greeting. We're now in a position where we can run our code, and with the little library that you're provided with, we can see that it shows us the methods that are in our main class. I can type 2 to run it, and we can see that it says it's running it. It tells us no values are required to run the method, and it returns the string hello CO4073. So we'll move on to the next one. This wants us to write a method called repeat. It says it has one parameter, a string, and it should return that string, but that string should be listed twice with a space in between. So let's do that now. We'll say static string because it's going to return a string, a piece of text. It tells us the method is called repeat, and it does need something to do its job. So within the bracket, we're going to say it's going to have that parameter. The type is a string, and then we can choose the name of the parameter. In this case, the parameter is some piece of text that we're going to repeat. So I think text is a good name for that. Once I've done that, I'm going to open the braces where the logic's going to go. And to solve this particular problem, we need to take this text, we need to concatenate it with a space, and then we need to concatenate it again with the text the same text thing again. So we've got a bit of an example here in that we're concatenating the word hello followed by a space with the name variable in the greet method. So this is really quite similar. I'll do it, I'll create a variable and I'll return that variable. So I'll say string repeated text equals, and then I'm going to say text, and then we'll concatenate that with a space. So all I'm doing is creating a string literal where the only contents of it is a space. This is not really any different to this, except that the only thing in my string literal down here is a space, whereas this has got the word hello, a space, and then a module code. And then I'm going to put text on there as well. And then the final thing we need to do is to return that repeated text. Again, we'll just run this for good measure to check it works. We'll use the repeat method. Some text is what I'm going to type, and you can see when it runs, it puts the text I typed, followed by a space, followed by the text I typed again. So that's the second method. Now, the third method is a little different. It tells us that we need to write a method called magic number. It says it doesn't have any parameters, so the brackets are going to be empty, and it should return the number 42 or any other integer of our choosing. So what it doesn't say explicitly is what the return type should be. So before we've been using string, which represents text. I want to return this time an integer. So I'm going to say static, because my method needs to be static, and I'm going to return an int rather than a string. The method we're asked to call it magic number, so I'm just going to copy and paste that. We don't require anything for it to do its job. We need our braces for our logic. I'm going to, rather than have a variable that I then return, I'm just going to put it all in one line now. I'm going to say return. And it says the number 42 or any number of my choosing. I'll go with 42. And then we'll add a semicolon at the end of the line. Again, we can run that for good measure. Run our magic number method. And it tells us it's running the method. No values are required to run it. And it's returning the integer 42. If you've done this and it returns a string, because some people have put 42 in quotes and put the string type as a return, you'll want to change that to int and make sure it just returns. And it just to show you what happens if we accidentally try and return a string but leave the return type as int, we'll get a compiler error that says we need to return an int, but we're providing a string. So we'll turn that back into the integer literal 42. The next method we're asked to write asks us to create a method called add. So I'm going to do that, static, and it's, if we look closely, it should return the sum of two integers. So the sum of two integers is generally safe to return another integer. There are some times when that might not be the case, but for now we'll return an integer, and we're going to call it add. It needs two parameters. I'm going to call them num1 and num2. I'm going to say int num1, int num2. Just because of the mechanism by which the library that runs the methods works, even though it would be valid code to use, say, a and b as the variable numbers, my library won't let you do that. You need at least 2 characters for the variable name. So I've used num1 and num2. It's always a good idea to try and make your variable names as meaningful as possible. So to solve this problem, all we need to do is return the 2 numbers added together. So we can just say num1 plus num2, and that will add those 2 values together. Again, if we want to run that, we can choose add, which happens to be method number 1. These are in alphabetical order. So we'll say 1, we'll add 3 and 4 together, and we can see that it returns the integer 7. So the next part of the task asks us to write methods to convert between units of time. It says that each method should have one parameter that's an int and should return another int. It does say to test each one after we create it, but to save time, I might skip some of the testing. Hopefully it should be relatively self-explanatory. So the first one asks us to convert minutes to seconds. So let's do that. We're going to say static int. The method is going to be called minutes to seconds. Again, I'm just going to copy that, paste it there. We need to declare an integer variable as a parameter. It's a good idea to name the parameter with what it will be. So this is going to represent a number of minutes. We could just use minutes if we wanted to, but for the first one, and keep it extra clear. To convert minutes to seconds, we simply multiply it by 60. So we'll return number of minutes times, we use the asterisk for that, 60. I will test this one just to give you a quick demonstration. Here we go, minutes to seconds is number 6. I will convert 3 minutes to seconds, and we can see it's giving us the value 180. A bit like playing darts. Okay, hours to minutes. So same principle, static int hours to minutes. I could have copied it, but maybe should have done int. So we're going to give it hours. I'll just use hours. It is the number of hours, but hopefully you can get the idea. To turn hours into minutes, we multiply hours by 60. So we'll say hours times 60. You can be assured that that should work. Days to hours. Hopefully you're getting the idea by now. Days to hours. One thing of note is that when you name a method, we use the first word in the method name as all lowercase, and then we capitalize the first letter of every subsequent word in the name to follow the correct Java naming convention. Again, here the value we've got is days. To convert it to hours, we simply multiply days by 24. Weeks to days. Hopefully everybody knows there are 7 days in a week, so we can say static int week to days int weeks. Don't have to have a space there. Normally don't. I'll delete the space I put in by accident, and we'll return weeks times 7. And then years to weeks, we are going to make a little assumption here, which isn't quite correct, but this allows us to continue working with the int data type. If we wanted to have a more accurate result, we could use a double, but for the purposes of this task, I have to assume exactly 52 weeks in a year. So we're going to say static int years to weeks, int years, and there are 52 weeks in a year, return years times 52. And then seconds to milliseconds. Now there are 1,000 milliseconds in a second, and this says rather than using the int data type for the method, we need to use long, as later we'll convert it to milliseconds, and that would be larger than an int could hold. So this method would be slightly different in that the return type is going to be a long integer. So a regular integer uses 32 bits to store its value. It can store negative values as well, so 1 bit is used for the sign. So we've got 31 bits left for the magnitude of a regular integer, which is about 2.1 billion. It's about the largest value you can store in a regular integer. But with a long integer, you have 64 bits. Again, 1 is the sign. So the largest number you can, or the highest number you can store in a long integer is 2 to the power 63 minus 1. So it's much larger than that 2.1 billion limit that we've got. So this method is going to return a long integer. Again, the method, I'm going to copy the name so I don't mistype it. We're going to pass in the number of seconds. I've forgotten to put the data type here. So unlike some languages which don't require you to supply the data type, Java's very fussy. So we're going to say int seconds, and then we're going to return the number of seconds multiplied by 1,000. Now, at the minute, I've used int as a data type here, which could cause problems if the result of the calculation of multiplying seconds as an integer by 1,000 exceeds 2.1 billion. So there's different ways I can resolve that problem. I could say multiply 1,000L, which means this is a long integer, by seconds, and that calculation will be implicitly converted to a long integer. Or we could actually say use long here. Now Java's quite forgiving. If we pass an integer to a method that requires a long, it will be fine with that. So perhaps the safest option is both to have a long integer as the parameter and also make it clear that we're multiplying it by a long value. If we want to be really clear what's happening, we could instead declare a variable. We could say long milliseconds and assign that the result of doing that calculation, and then we could return the number of milliseconds. I might leave that like that for now. Yeah, so they're all the methods where for time conversion. Now, the final section wants us to use different methods that we've already written in the solution to our problem. So this is a process where we have a problem, we break it down into smaller steps. It's a process known as decomposition, and it's something we do a lot in programming, because ultimately trying to solve one big problem in one go it's very difficult to hold all that information in our brain. So instead, we break it down into smaller steps. Now, these problems are trivial. You can probably work out that convert the number of weeks to hours, we multiply it by 7, and then we multiply it by 24. But to make a point of learning how to both call other methods and to break a problem down, we're going to write it by calling some of the methods that we've already written. So let's start the first one, weeks to hours. We're going to say static int, copy the name of the method here again. So the input for this is going to be a number of weeks. Again, I've forgotten the data type. There we go, it's an integer. So the first thing we can do is get the number of days. So we could say int days equals, and we can call our method that gives us, given a week, the number of days, we can say int days equals week to days and pass it the number of weeks. So now we found the number of days without having to do an additional calculation. And then the second stage of this, we can ask for the calculation method, or use the method that we've already written that converts days to hours. So we can say int hours equals days to hours, and we can provide it with our days variable. And then finally, we can return the number of hours. So let's just test that one. We haven't tested in a little while. So I'm just going to run my program, and we'll find the weeks to hours method, which is number 12. So we'll run that. Let's just do 1 week to start with, because I can do the maths in my head for that, which is going to be, or maybe I can't. We can do 7 times 24. That should be somewhere around 168 mark. So let's try that 1 week. There we go, we've got 168. Just to prove it works, we'll run that twice, and this time we'll do 2 weeks. So we'll do again 12 weeks to hours, 2 weeks, and it should be 336 hours. So let's continue with this. Let's now do weeks to second, static int weeks to second, int weeks. Now, you might have noticed, well, we've done half of this already. We can do it. We can use weeks to hours to get it to hours first of all, and then convert it to seconds. So we'll say int hours equals weeks to hours. Convert our number of weeks to hours. Oops, didn't want an extra brace there. That was a mistake. Let's get rid of that. And then what I did want was a semicolon. We can call the method that converts hours to seconds. So we can say hours to, have we done hours to seconds? We maybe not. Oh, we've still got to do hours to minutes first. So we need to get minutes first. So we say int minutes equals hours to minutes. We'll pass in the number of hours, and then finally we can convert the number of minutes to seconds by calling minutes to seconds and passing in the minutes. Now I could store that in a variable called seconds and return that, or I could be a bit more lazy and I could just write return minutes to seconds rather than putting it in a variable first. That's equally fine. Years to hours. So what have we got so far? Have we got anything that converts a year down to anything else? We've got years to weeks. That's probably the biggest jump we've got to start with. So let's start by converting years to weeks. So we'll write our method, static int years to weeks, int years. Oh, hang on a minute. Years to hours. There we go, not years to weeks. Let's quickly fix that. It was years to weeks that we've already got. So we can say int weeks equals years to weeks and pass in the number of years. And then have we got a weeks to hours? Let's have a look. Do we have weeks to hours? We do. So we can use that and pass in the number of weeks. And we can then just return that. So that's kind of handy. We've got hours from years with just 2 lines of code. The next one is years to days. We're going to say, well, I'll just copy it because I'm lazy. Years to days, int years. Again, we can do years to, what have we got so far? Weeks to seconds. So we've got years to weeks, we've got years to weeks. So we can again say int weeks equals years to weeks. pass in the number of years, and then just we could multiply by 7, but we're going to use our if we got a week to days one, week to second, week to hours. We have got weeks to days, so we can say return weeks to days and pass in the weeks. Years to seconds. We want to do whatever we can to get to the smallest component from years. We've done to hours. That's probably the best thing to start with. So we'll do years to hours. So let's write our method. Static int years to seconds, int years. And we will first of all, what do we say it was? Years to days. We got better than that? We got years to hours. Let's do years to hours. Hours equals years to hours. We'll pass in the number of years. And then we want to get that to seconds. So we can say return hours to seconds. Oh, we haven't written an hours to seconds one yet. So we're going to have to do hours to minutes. And then do minutes to seconds. So we can say int minutes equals hours to minutes. Hours int, well, we can return this now. We can say return minutes to seconds, and we want minutes. And then our final one is years to milliseconds. This is quite easy to have exceed 2.1 billion. So what we're going to do, we'll say static long years to milliseconds. Int years. Now we've already got years to seconds, and we also created, if you remember, we did seconds to milliseconds earlier on. So we'll say int seconds. Well, actually, we be careful here because we potentially might need a long. So we're going to say long seconds equals years to seconds and pass in the years. And then we can convert it to milliseconds. So we can say, I'm going to put it in as a variable. We'll say milliseconds equals seconds to milliseconds and pass in the seconds. So that will give us the number of milliseconds, and we can return the milliseconds. So to check that's working, I appreciate there's scope. We haven't tested every method. I appreciate the scope for the maths to have gone wrong, but the important thing is here that we're getting a value that is over 2.1 billion if we put in probably even just 1 year. So I'm going to run that. I'm going to find the years to milliseconds one, which is number 16. I'll put in quite a large number of years. Let's go for 50 years. And you can see that number here is well over 2 billion. So that's a million, that's a billion. So it's 1,572.48 billion is the value that we have there. That was the last task. Hopefully you found that useful. Thanks for watching.